Picture this, okay. It is the absolute peak of summer. I'm talking about that brutal stretch of August where, the heat just sits heavy and distorted over the pavement.
Oh, yeah. The worst part of the year.
Exactly. And the air conditioning in your house has been running nonstop since like 10 in the morning.
Right, just working overtime.
Yeah. And you walk past the thermostat, and despite being optimistically set to, say, 70 degrees, it is stubbornly holding at 76.
Which is incredibly frustrating.
It really is. The vents are blowing, but the house just feels, I don't know, it feels thick. And then the real gut punch arrives in your inbox, right? The monthly power bill.
Let me guess, it's astronomical.
Oh, it's the highest it has ever been. And in that moment, staring at that terrifying number, you are entirely convinced your air conditioning unit is on its last legs, just dying this slow, expensive death.
Well, and I mean, it's a completely understandable assumption to make, We are just naturally wired to look at the big, noisy, visible piece of machinery sitting out in the side yard and blame it for the problem.
Right, because it's right there.
Exactly. It is the loudest component of our home's comfort system, so it draws all of our attention.
Well, today, our mission for this deep dive is to potentially save you thousands of dollars and, more importantly, solve the actual root cause of those home comfort issues.
Which is huge.
It is. To do that, we have some really fascinating source material to dig into today. We're looking at a deep dive into HVAC performance from an industry show. It's called Cool Talk with Hartzell.
Yeah, that's a great show.
It is. And they recently broke down some truly startling data compiled by the Department of Energy. And spoiler alert here, the problem probably is not that expensive metal box outside your house.
No, usually it's not. To really understand what is happening to your comfort and, your wallet, we have to shift our focus away from the visible machinery.
Okay, so where are we looking?
We need to look up into the attic at the hidden delivery system that's just snaking through the framing of your home, the ductwork. Because as the data from the Department of Energy shows, you simply cannot diagnose the source equipment without first looking at the pathway that actually carries its output.
Okay, let's unpack this, because the sheer scale of the invisible energy loss happening in homes right now is just, well, it's staggering.
It really is.
Before we talk about how to fix anything, we need to understand the magnitude of the leak. So the Department of Energy has this piece on their Energy Saver site, and I mean, their headline statistic should honestly be printed on every electric bill in the country.
Oh, absolutely.
According to their field research, 20 to 30% of the conditioned air that moves through a typical residential duct system is just lost.
Just gone.
Gone.
Yeah.
It never even makes it to your living room. It is bleeding out through leaks, holes, and poorly connected joints.
And what's fascinating here is the physical reality of what that 20 to 30% loss actually means. Percentages can sometimes feel a bit abstract.
Sure.
So let's translate that into dollars and the physical environment. If your power bill in August hits $400, you are spending between $80 and $120 a month just cooling the fiberglass insulation in your attic.
Wait, really? $120?
Yeah. You are literally paying a premium utility rate to air condition an uninhabited, unfinished space.
That is, up to $120 a month just evaporating into the rafters? That hurts.
It does hurt.
And looking at the data, the financial hit gets exponentially worse when you factor in the physical climate up there.
Right, because you have to consider the thermodynamics of the space. The experts on the Cool Talk show, they bring up Central Oklahoma as a prime example, but honestly, this applies to almost any region with a hot summer.
Yeah, anywhere the sun beats down on a roof.
Exactly.
Yeah.
During peak sunlight, the ambient temperature inside an asphalt shingled attic can easily hit 140 degrees.
Wow, 140.
Yeah. So if you have a hole on the supply side of your ductwork, like the tubes pushing the cold air out, you are pumping precious, expensive 55-degree air into a 140-degree oven.
If it's bad enough.
But the real catastrophe happens if you have a leak on the return side.
Okay, the return being the large vents that pull air from the house back into the system to be cooled again, right?
Correct. The system uses a powerful blower motor to pull air in. So if there is a hole in that return duct up in the attic, the blower motor doesn't care where the air comes from.
It just wants air.
Right. It just pulls from the path of least resistance. So
right.
Instead of gently pulling nice 75-degree air from your hallway, it actively sucks 140-degree superheated attic air straight into the air conditioner.
Oh my gosh. So the AC unit receives air that is effectively boiling.
pretty much.
And it has to work incredibly hard just to cool that air down to normal room temperature, long before it even begins the job of cooling your actual house.
Exactly. It creates a massive thermodynamic penalty. I mean, it forces the compressor to run in endless, continuous cycles, which just burns a tremendous amount of electricity.
And I imagine that's not good for the machine either.
Not at all. It creates immense wear and tear on the mechanical components. The unit is going to die much faster than its expected lifespan.
Wow.
And not because it was a poorly manufactured unit, but because it was fighting an unwinnable war against the ambient heat of the attic.
It's like, imagine running your car's air conditioner on maximum blast, but leaving the windows completely rolled down while driving through Death Valley.
That is a perfect analogy. That is essentially what we are talking about here.
Which naturally makes you wonder about the professionals we hire to maintain these systems. Like, if the math is this terrible, and if 20 to 30% of our money is bleeding out into the attic, why is inspecting the ductwork almost never the first thing a technician suggests?
That is the million-dollar question.
Right. Like, when you call them about a warm house and a high bill, why don't they go straight to the ducts?
Well, this raises an important question about industry incentives and just the physical nature of residential construction.
Okay.
The source material points out two main reasons why contractors routinely ignore the ductwork. The first reason is purely practical. Residential duct systems are entirely invisible to the homeowner.
True, you don't really see them.
Right. They are buried under mounds of blown-in insulation. They're snaked blindly through these awkward wooden roof trusses, and they're sealed behind drywall. You have absolutely no way to casually inspect them.
Right. I mean, you can't just walk through the hallway and notice a disconnected duct the way you'd notice, like, a leaky faucet in the kitchen.
Exactly. Out of sight, out of mind. And the second reason is deeply tied to the business model of HVAC contracting itself.
How so?
Fixing ductwork is miserable, unglamorous labor. There is no shiny new branded box installed on the side of the house to show off to the neighbors, you know?
I see.
It involves a technician putting on a protective Tyvek suit, strapping on a respirator, and literally crawling on their belly through a 140-degree, incredibly itchy, dusty, cramped space.
That sounds awful.
It is. So from a purely financial perspective, a lot of contracting companies would simply rather sell you a brand new $15,000 high-efficiency air conditioning system.
Because it's easier and makes more money.
Exactly. The profit margin on a shiny new unit is significantly larger, and the labor is much cleaner than crawling around in fiberglass patching holes.
There is an anecdote in the source material from an industry veteran, Dave Hartzell, up in Kingfisher, Oklahoma, that perfectly illustrates this blind spot.
Oh, the Hartzell story is great.
Yeah. He notes that when he goes out on a service call and a frustrated homeowner is complaining that their system is undersized or failing, the very first thing he does before he ever opens his laptop to write up a quotes for new equipment is crawl into the attic to look at the delivery system.
And his diagnostic success rate is frankly shocking.
It is. He states that 8 times out of 10, the ducts are the primary problem.
8 out of 10 is an overwhelming majority. I mean, it suggests that most quote-unquote failing AC units are actually just victims of failing infrastructure.
Right. And the specific examples he gives are almost comical, well, if they weren't costing the homeowners so much money.
Seriously.
He talks about finding supply booths completely disconnected. But wait, real quick, before I keep throwing terms around, let's define the anatomy here. What exactly is a supply boot, a trunk line, and a plenum?
Good point. Let's map the system out. So the plenum is the main distribution box attached directly to the indoor unit. Think of it as the heart.
Okay, the heart. Got it.
Then the trunk lines are the massive main metal arteries branching off from that plenum. The flexible plastic ducts then branch off from the trunk lines like smaller blood vessels.
Makes sense.
And finally, the supply boot is the metal transition piece at the very end of the line. It's the part that connects the round, flexible duct to the square vent grill you see looking up at your ceiling.
Perfect. So Hartzell finds these metal boots just laying on the attic floor joists, entirely severed from the ceiling register.
Unbelievable.
So the homeowner has been paying to cool their attic for 5 straight summers, just blowing perfectly good 55-degree air into absolutely nothing.
Yes, just dumping it into the attic.
While sitting in their living room sweating, completely convinced their equipment is garbage.
You basically have a fully functional cooling plant attached to a severed pipe.
Exactly. So, okay, we understand why the industry tends to ignore these vital delivery tubes. But we have to look at why they fail in the first place.
Right, because they do fail a lot.
Because it's not always a dramatic, completely disconnected pipe, right? Like, if you are listening to this and you live in a house built, say, 10 or 15 years ago, what is actually happening to the materials above your ceiling?
It's a great question.
Why do these metal and plastic tubes start leaking so badly over time?
Well, it really comes down to the unrelenting physics of thermal expansion and contraction. The Department of Energy points out that even a perfectly installed, top-of-the-line duct system, one that was sealed meticulously on day one, will loosen over time. Think about the extreme environment they live in up there.
Yeah, that 140-degree heat we talked about.
Right, but also the cold. Your attic might drop to 20 degrees on a freezing winter night, and then bake at 140 degrees in the summer. So the sheet metal components of the ductwork are constantly expanding when they heat up and contracting when they cool down.
So they're just expanding and shrinking millimeter by millimeter, day after day, season after season.
Exactly. And over a decade, that constant micro-movement is devastating.
I can imagine.
The sealant pastes dry out and turn brittle. The metal screws that hold the joints together literally back themselves out of the sheet metal due to the microscopic vibrations of the airflow and those massive temperature swings.
The screws just unscrew themselves.
They do. And the structural failures almost always happen at the transition seams. So like where the flexible plastic duct is stretched over the metal collar of the plenum, or where the boot is screwed into the ceiling drywall, or where two sections of the main trunk line are joined together.
So it's the joints that are the weak points.
Yes. A system that passed inspection perfectly on the day the house was built might easily be leaking 15% of its air by year 10, strictly through the basic laws of physics.
Here's where it gets really interesting, though.
Oh, yeah.
Because when people hear they have a leak in their ducts, or maybe they spot a torn piece of insulation up in the attic, their first instinct is usually to reach for the most famously named tool in their garage.
Of course it is.
But the source material highlights this massive, highly specific irony. Duct tape-like, the standard cloth-backed silver tape you can buy at any grocery store or hardware store, is arguably the absolute worst material you can use on an actual duct.
It really is one of the great misnomers of modern hardware, and it causes endless headaches in the HVAC industry.
I bet. Because the adhesive on that standard cloth tape simply cannot handle the environment.
Not at all.
The Department of Energy explicitly warns against using it because the extreme temperature swings of an attic destroy the chemical bonds. The glue dries out into a useless powder, the cloth backing loses its grip, and within a year or two, the tape is just hanging off the metal joint like a dead piece of snakeskin.
Just doing absolutely nothing to stop the air from escaping.
Right.
Yeah, the Department of Energy has a very specific field-tested recommendations for what actually works permanently. If you want to seal a duct, they recommend two specific materials.
Okay, what are they?
The first is mastic. Mastic is a thick, gooey paste, sort of the consistency of peanut butter. A technician brushes or trowels it directly over the metal joints and screws.
Like painting it on.
Exactly. And it cures to a hard finish, but crucially, it maintains an elastic quality. It stays flexible enough to handle decades of expansion and contraction without cracking.
That makes sense.
Right. And the second approved material is a specialized tape, but it shares no DNA with the cheap cloth stuff.
Right.
It is a metallic foil-backed tape that has the rating UL 181B printed directly on the outer layer. That specific rating means the acrylic adhesive has been chemically formulated and tested to actually survive the hostile baking environment of an attic.
Okay, so theoretically, an ambitious homeowner could grab a tub of mastic, put on a mask, crawl up there, and start painting every seam they can find.
They could.
But painting the exposed joints you can easily reach doesn't really solve the problem if the most massive leak is buried under 3 feet of blown-in cellulose insulation. Or worse, hidden vertically down inside a wall cavity.
Right, which happens all the time.
So how do the professionals actually track down these invisible buried leaks?
Well, this is where the industry relies on a highly systematic test, seal, retest protocol. The professionals don't just guess by looking around with a flashlight. They use diagnostic tools to make the invisible air currents visible.
Oh, that's cool.
Yeah, the first tool is called a duct blaster.
A duct blaster. Sounds intense.
It does. It is essentially a highly calibrated, variable speed fan that they temporarily attach to your duct system, usually at the main return vent.
Okay.
They seal off all the other vents in your house with adhesive plastic, turn on the fan to pressurize the entire duct system, and then use digital manometers to measure exactly how much airflow is required to maintain that pressure.
Wow, okay.
It gives them a precise, undeniable percentage of leakage.
That's great because it completely removes the guesswork. You know exactly what the baseline loss is before you even start looking for the hole.
Exactly. And the second tool is even more visual. It's a smoke or fog test.
Oh, like a fog machine?
Literally, yes. They blow theatrical fog, the exact same safe, dense vapor used on stage at a rock concert, through the pressurized duct system.
That is brilliant.
Then the technician goes up into the attic or walks around the exterior of the house and simply watches to see where the fog escapes. You will see thick white smoke rising up through the attic insulation, bleeding out of wall cavities, or sneaking around ceiling light fixtures.
Oh man, it just instantly highlights every single failed seam, backed out screw, and disconnected boot in the entire house.
Precisely.
That is such a brilliant application of technology. You force the invisible air to take on a physical shape so you can map the breaks in the infrastructure.
It works perfectly.
And the goal, according to the Department of Energy, is to get that overall system leakage down under 10%. They note that many older systems start at a staggering 30 or 40% leakage rate, and with a solid day of testing and sealing, can reliably be brought down well under that 10% threshold.
And looking at those percentages naturally invites a conversation about the economics of all this.
Right, because hauling calibrated fans, theatrical fog machines, and technicians in hazmat suits into an attic sounds incredibly labor-intensive.
It is a lot of work.
So what does this all mean for the wallet?
Yeah.
Like, are we actually saving money doing this?
Oh, absolutely.
The source data breaks this down beautifully. For a typical market, a comprehensive professional job where they run the duct blaster, find the leaks with fog, seal everything properly with mastic, and perform a final verification test runs around $800 for a small, straightforward system.
Which really isn't too bad.
No. And it can scale up to about $2,500 for a sprawling 1,500 square foot ranch house with complex, deeply buried, flexible ducting.
Let's contextualize that investment, though. If your duct system is compromised enough that you are bleeding $80 to $100 a month on your summer electric bill, plus the excess heating costs in the winter.
Right. It adds up fast.
Very fast. A professional sealing job easily pays for itself in just 1 to 2 years. It is consistently ranked as one of the highest return on investment improvements you can make to a residential property.
Wow.
But if we connect this to the bigger picture, the financial savings are truly only half the story.
Yeah, the other half being the actual lived experience of a house. Because, I mean, nobody thinks about their HVAC system when it's working beautifully. They only think about it when they're miserable.
Exactly. The impact on physical comfort and indoor air quality is profound, and we need to look closer at the physics of that blower motor we discussed earlier.
Okay, the big vacuum.
Right. When a return duct is leaking, it isn't just a passive hole losing air. A leaky return creates profound negative pressure. Like you said, it acts as a massive vacuum cleaner.
And it's a vacuum cleaner positioned in the dirtiest, most hostile environment in your house.
Exactly. The experts on the Cool Talk source refer to a leaky return duct as a literal humidity machine.
Yes, a humidity machine.
Yes, because that blower motor is pulling hundreds of cubic feet of air per minute. So a hole in the return is constantly vacuuming unconditioned, fiberglass-filled, deeply humid air straight out of the attic and blowing it directly over the cooling coils and right into your bedroom. If you have ever been in a house where the air conditioning is running constantly, the thermostat insists it is cold, but the air feels sticky, heavy, and you just can't get comfortable.
Oh, I've been in that house.
Right. That is almost always a leaky return duct dragging heavy attic humidity into the living space. By sealing the ducts, the vacuum effect stops, the air quality immediately jumps, the heavy humidity drops, and the system runs shorter, much more effective cooling cycles.
But you know, I am listening to this and thinking about the homeowner whose AC unit is genuinely 20 years old.
Right.
It sounds like a dying lawnmower. It rattles the windows when it turns on, and the fins are completely rusted out.
Yeah, we've all seen those units.
Is there a point where we are pushing the repair narrative too hard? Like, are there times when the equipment actually is just dead and no amount of mastic is going to save it?
Oh, we absolutely have to acknowledge that reality. I mean, air conditioners are heavy mechanical devices with finite, predictable lifespans.
Right.
If your compressor is internally seizing up, or if your system runs on R22 Freon, which is an obsolete, environmentally phased-out refrigerant that costs a fortune to replace.
Yeah, you don't want to mess with that.
Exactly. In those cases, your ductwork could be completely flawless and you would still be entirely miserable. Units definitely die, and they do require full replacement.
So mastic and foil tape are not a silver bullet for every single house on the block.
No, but here is the essential synthesis of the core lesson from both the Department of Energy data and the industry veterans. If your air conditioner is dead and you invest $15,000 in a top-tier, variable-speed, ultra-efficient new unit, but you connect it to crusty, leaking 20-year-old ductwork, the promised efficiency of that new unit will never materialize on your electric meter.
You're just wasting it.
You will just be blowing highly efficient, extremely expensive cold air straight into your attic. You have to fix the delivery arteries before you upgrade the heart.
I love the analogy they use in the source material for this exact scenario. They say, a great chef cannot save a meal if you serve it on a paper plate with a hole in it.
That is brilliant. It perfectly captures the futility of putting brilliant technology onto a broken foundation.
It really does. The quality of the source simply does not matter if the delivery mechanism is fundamentally compromised.
Exactly.
But to bring all of this together for you listening, the main takeaway from all this Department of Energy data and HVAC industry insight is incredibly simple. Test before you replace.
Yes, test first.
The next time the dog days of summer roll around,
Yeah.
your power bill spikes unexpectedly, or your living room starts to feel sticky and damp despite the vents blowing cold air, do not immediately reach for the phone to get quotes on massive new equipment.
Hold off on that call.
Your very first step should be to grab a flashlight, find your attic access panel, and start looking at the hidden plumbing.
You know, this entire deep dive reveals a really fascinating and somewhat flawed human bias.
Oh, how so?
We have a profound tendency to focus on replacing the highly visible, expensive components in our lives when things go wrong. We inherently want the shiny new fix.
Right, the new toy.
Yeah, but we almost always ignore the boring hidden infrastructure that actually makes the system work, which honestly raises an important question to ponder long after we sign off today.
What's that?
What other systems in our lives, our businesses, or even our daily habits are we currently trying to fix by buying a flashy new solution when the real problem is just a leaky, invisible foundation we haven't bothered to inspect?
Wow, that is the perfect question to leave hanging in the air. So the next time you feel a draft, remember the hidden window in your ceiling. Thank you so much for joining us on this deep dive. Stay cool, check your infrastructure, and we will catch you next time.